Sargassum is a type of brown seaweed that floats on the ocean's surface. For centuries, sailors have known about the Sargasso Sea. This is a calm area in the North Atlantic Ocean where the seaweed naturally gathers. It forms large floating mats. These mats have always been a vital habitat for marine life. Many species of fish, sea turtles and crabs use the sargassum for food and shelter. It's like a floating nursery for the open ocean. This ecosystem has existed in a delicate balance for a very long time. It provides a unique and important environment far from any coastline. However, something has changed dramatically in recent years. We are now seeing a new and enormous accumulation of this seaweed. This is called the Great Atlantic Sargassum Belt. It is the largest bloom of macroalgae in the world. This belt can stretch all the way from the coast of West Africa to the Gulf of Mexico. Its sheer size is hard to imagine. It's so large that you can see it from space. This is not the same as the historic Sargasso Sea. It's a new phenomenon that has appeared and grown rapidly since 2011. This massive expansion is causing a lot of concern for scientists and coastal communities alike. The scale of this new sargassum belt is truly staggering. In some years, the total mass of the seaweed has been estimated to be over 20 million tons. That's heavier than hundreds of aircraft carriers combined. This is not a small, localized problem. It is an ocean basin scale event that is reshaping our understanding of marine ecology. The belt is not a single, solid mat. Instead, it is a long, broken-up chain of floating sargassum patches. These patches drift with the ocean currents. Their movement and growth are influenced by winds, waves, and the availability of nutrients in the water. This sudden and massive growth is why we are so concerned today. The sargassum that washes ashore is no longer a small, manageable amount. It arrives in overwhelming quantities, creating huge problems. These problems affect tourism, fishing, and the health of coastal ecosystems. We used to see sargassum as a natural wonder of the open ocean. Now, we must study it as a serious environmental challenge. My research and the work of many others has focused on understanding why this is happening. We need to know what is feeding this incredible explosion of seaweed growth across the entire Atlantic Ocean. In the open ocean, sargassum is a source of life. It creates a critical habitat, often called a golden floating rainforest. It provides a safe place for young sea turtles to grow. They find food and hide from predators within the dense mats. Many species of fish, like mahi-mahi and tuna, are associated with these floating islands. They hunt for the smaller fish and crabs that live there. This ecosystem is a key part of the food web in the nutrient-poor waters of the open Atlantic. Without these sargassum mats, many species would struggle to survive their early life stages. It is a vital part of a healthy ocean environment. However, when this sargassum reaches the coast in massive quantities, its role changes completely. It transforms from a source of life into a major threat. The thick mats block sunlight from reaching the sea floor. This kills the seagrass beds and coral reefs below. These are also important nursery habitats for many marine species. The sargassum smothers them, cutting off the light they need to live. As the seaweed blankets the nearshore waters, it also changes the water chemistry. This creates a stressful environment for marine life that is not adapted to such conditions. The balance of the coastal ecosystem is severely disrupted by these huge inundations. When the sargassum washes up on the beach, it begins to rot. The piles can be several feet deep, covering entire beaches. As it decomposes, it uses up oxygen in the water. This creates low oxygen or anoxic zones near the shore. These zones can cause large fish kills. The fish and other organisms are essentially suffocated. The rotting seaweed also releases a gas called hydrogen sulfide. This gas has a strong, unpleasant smell like rotten eggs. This smell makes the beaches unusable for tourists and residents. It creates a significant public health concern for people living and working near the coast. The consequences for coastal communities are devastating. Tourism is a major part of the economy for many countries in the Caribbean and Mexico. When beaches are covered in rotting sargassum, tourists stay away. Hotels, restaurants, and local businesses suffer huge financial losses. Fishermen also face major challenges. The thick mats can entangle their fishing gear and boat propellers. They also find it harder to get their boats out to sea. The decline in fish populations due to habitat loss and fish kills further impacts their livelihoods. This seaweed invasion is not just an environmental problem. It is a serious socio-economic crisis. For many years, my research has focused on what fuels the growth of algae. To understand the sargassum explosion, we had to look at its food source nutrients. Just like plants on land, seaweed needs nutrients like nitrogen and phosphorus to grow. By analyzing the tissues of the sargassum itself, we can find chemical clues about where it has been. This is similar to how a person's hair can show what they have eaten. Our analysis of the sargassum showed very high levels of nitrogen. This told us that the seaweed was getting its nutrients from new human-related sources. Our research pointed to two major sources for these nutrients. One is the Amazon River. Deforestation and the increased use of fertilizers in agriculture have led to more nutrients washing into the river. These nutrients are then carried far out into the Atlantic Ocean. The Amazon's plume of fresh, nutrient-rich water now extends much farther than it used to. This creates a fertile pathway for sargassum to grow. The timing of the sargassum blooms often follows the peak discharge from the Amazon River. This provides strong evidence for the link between land-based activities and ocean-based problems. Another important source is upwelling off the coast of West Africa. Upwelling is a natural process where deep, cold, nutrient-rich water rises to the surface. However, this process can be intensified by changes in climate and dust from the Sahara Desert. This dust, which contains iron and other nutrients, blows over the ocean and fertilizes the surface waters. When these natural processes combine with increased nutrient pollution from rivers like the Congo, they create a perfect recipe for explosive sargassum growth. The seaweed gets a seed population from this region before it drifts westward toward the Americas. So, the Great Atlantic Sargassum Belt is not caused by a single factor. It is the result of a combination of human impacts and natural ocean processes. Increased nutrient pollution from rivers driven by agriculture and deforestation is a major factor. Changes in ocean currents and increased upwelling also play a significant role. Climate change may be making these conditions more frequent and intense. It is a complex puzzle, but the pieces are coming together. The evidence clearly shows that human activities on land are having a massive and direct impact on the health of our oceans. There is no easy solution to the sargassum problem. We cannot simply stop it from growing in the open ocean. Doing so would harm the important ecosystem it supports there. The focus, therefore, must be on managing the impacts when it reaches the coast. Many communities have resorted to using heavy machinery like bulldozers and excavators to clear the beaches. This is expensive and can cause further damage to the beaches through erosion. It is a short-term fix that does not address the root cause of the problem. We need more sustainable and innovative approaches. One promising area of research is finding ways to use the sargassum. Scientists and entrepreneurs are exploring its potential as a biofuel, fertilizer, or even as a component in building materials. If we can create value from this seaweed, it could turn a costly problem into an economic opportunity. This would help offset the high costs of cleanup and create new jobs. However, these technologies are still in development. We need to ensure that any use of sargassum is safe and does not introduce other environmental problems, such as heavy metal contamination, into the products. Ultimately, the most effective long-term solution is to reduce the amount of nutrients entering the ocean. This requires significant changes in land management, particularly in the large river basins that feed the Atlantic. This means improving agricultural practices to reduce fertilizer runoff. It means investing in better wastewater treatment for cities. It also means protecting and restoring forests and wetlands, which act as natural filters for nutrients. These are huge undertakings that require political will and major investment. They are not quick fixes, but they are essential for restoring the balance of our coastal oceans. Because the Sargassum Belt is an international problem, it requires international cooperation. The seaweed does not respect national borders. It drifts from the shores of Africa to the Caribbean and the Gulf of Mexico. One country's actions, or inaction, can affect all the others downstream. We need to work together to monitor the sargassum blooms using satellites and other tools. We need to share data and research findings. We must coordinate our management strategies and invest in solutions together. Only through a united global effort can we hope to manage this golden tide and protect the coastal communities and ecosystems that it threatens.